Hello everyone! Today we're going to study topographic maps. We use them to identify different landforms with their elevation. So as you see here on the first page of your lab, you have an example of topographic map, the contour lines, and also the profile of the landform. So how to find the elevation? There are three ways to find the elevation on the topographic maps. First, with the spot heights. So for example, here you see a dot and 34, which means 34 feet above the sea level. Another way is with the benchmarks. Benchmark, you can see here BM and X and 24, which also indicates the elevation there. But these are spots where you can see this elevation. Another way is to use the contour lines. These are lines connecting points with equal value, equal elevation. And as you see here on this map, these lines, they have numbers in feet like 0, 10, 20. So this is the elevation above the sea level. So this is how to find the elevation. Today we're going to study the rules, and let me go to the rules now and see what exactly we're gonna study, how to use the topographic maps and how to find different landforms with their elevations. We're gonna start with rule number 1. This is your second page, and as you see here, it says a contour line connects points with equal elevation. As you see on this line, all the points here where it says 100, 100, 100 feet above the sea level, they have the same elevation. Rule number 2 is to find the contour interval, CI. So how do we find the contour interval? I made here a sketch for you. So these are the contour lines with different elevations. So let's say that one of those numbers is missing. To find what number is this, we have to know the contour interval. We subtract two lines next to each other, like for example 300 minus 200 is 100, or 400 minus 300 is 100. So this is actually the difference between the elevation of two lines next to each other. Number 3. Usually every fifth contour is darker. So as you see here, the fifth contour, and it's called index contour. So why is the index contour important? You will see that most of the topographic maps, they don't have these numbers. They're missing here. And to find the value of each line, we can use the bolded lines. We subtract two bolded lines next to each others, divided by 5, to find the elevation of each line. You see, here is the example. 500 minus 0 is 500, divided by 5 is 100. So 100 is the contour interval on this map. The next rule is about number 4, the elevation. On one side of the contour line, the numbers are higher, on the other side lower. As you see here, if we take 200, you see on this side the elevation is 100 feet, on the other side is 300 feet. Rule number 5, contour lines, they never cross one another, although they may touch at a vertical cliff. So as you see, they can come very close together, but they never cross. Rule number 6, contour lines have no beginning and end. Every line closes on itself, either on or off the map. They're like circles, small and huge circles. Number 7, if spaced apart, far apart, contour lines indicate a gentle slope. If spaced close together, they represent a steep slope. Here is the example. Number 7, as you see, when the contour lines are far apart, they indicate a gentle slope. When they are very close together, this is an indication of steep slope. This is how we identify the steep slopes on the map. And then we have rule number 8. Rule number 8 is about how to identify the river valleys. When crossing a valley or a draw, contour lines makes V-shape pointing uphill. As you see here, these contour lines, they have this V-shaped form. They pointing uphill, and the river is the dash line which is crossing through this V-shaped contours, but they have to point upstream or uphill. Rule number 9 is about the ridges. So the ridges are shown on the map with these contour lines which have this U shape and U pointing downhill. So this is indication of a ridge. The next rule is number 10. 10 and 11 actually they apply to this sketch here. A contour line that closes within the limits on the map represents a hill or a rise. Now look at this here. You can see that the close lines, this is an indication of the top of the hill. And the numbers, the elevation increases toward the top of the hill. However, the top of the hill shown with the close contour lines, and the X, the very top, is higher than the elevation of the last line. Let's see what is the contour interval here. We subtract two lines, 200 minus 150 is 50, right? Then we have to find half a contour. Half a contour will be half of 50, which is 25. Why we try to find half a contour? Because X here, or the very top of the hill, is a little bit higher than the elevation of the last line, which is 250. To find the X, we have to add 250 plus half a contour for X, and this is the elevation. 275 will be the elevation of X. So here is the hill. You see the shape, how it looks like. So we use half a contour to find the top of the hill. Then here is the rule number 12 about the depression. So you see this depression contours also. You can identify on the map very easily the depressions. And this is actually a hole. You see the difference between the hill and the hole. So here you see the numbers are decreasing toward the center or the bottom of the depression. And to find the X, or the elevation of the bottom of the depression, we use again half a contour. First, find the contour interval, which is 250 minus 200 is 50. Half a contour will be 25. So X will be 200. So the last line here on the bottom, minus half a contour, and it will be 175. So this is how we find the bottom of the depression.